Good morning. Shout out to first period. Hey. All right, guys. We're going to do page 2 of your study guide review. You do have a test coming up, okay? Number 11. If you take a look, there's a little dot here that tells you you are going to multiply. Make sure your roots are the same. If your roots are not the same, in this case roots, then you cannot multiply them. That's the only thing. Remember, keep your coefficients together, your radicals together. Two different ways you can work this problem. You can take a square root first, or you could go ahead and multiply first. I am going to actually just multiply. 6 times 2 is 12. Stays outside. Draw your square root. 4 times 9 is 36. Okay. X squared times x squared, when you multiply your like base, you actually add them together. So you're going to have x to the 4th. This one has a y squared, and that's the only one. After this, you can simplify. Now, if you look at your pink sheet, what's the square root of 36? It is 6. Nothing left over. And then you can start dealing with this one, okay? X to the 4th. 4 divided by 2 is x squared. Very good. Your y, 2 divided by 2 is 1. Do you notice there's nothing left under the radical? So your answer is 6 times 12, which is 72. X squared, y, any left over. And there's your final answer. But the correct answer is really plus or minus. But I'm not going to worry about that, okay? Remember, when you have an even root, you have two answers. Number 12. Look at number 11. We're going to move to number 12. Number 12. Here we go. Check out your roots. Are they the same? Both of them are cube root, so you can multiply them together, okay? All right. 2 times negative 1 is negative 2. There's an understood one here. Draw your cube root, okay? You could simplify first if you want. 20 times 500 is 10,000. If you need to, use your calculator, just like this, okay? Just type 20 times 500. See how you have 10,000? Your x's. 9 plus 4 is 13. Just like so. Okay? Your y. 14 plus 12 is 26. Your z. 4 plus 8 is 12. Just like that. And now you can simplify. And now you can simplify. Here we go. Look at your pink sheet. Look at your cube root. Okay. Here's your cube root. What is a cube root of 10,000? See how there's not one? However, a cube root of 1,000 is 10. So, take 10,000, divide it by 1,000, because there's a perfect root there, and that comes out to be 1,010, just like that. You guys can't see that very well, can you? That's a terrible pen then. There you go. Okay? Now you can start to simplify. What's a cube root of 1,000? 10, with a 10 left over. 10 times negative 2 is negative 2. Leave yourself some space. Write your cube root. 10 is left over. Take a look at your x. What is 13 divided by 3? 4 with 1 left over. You guys see that right there? 13 divided by 3 is 4. 4 times 3 is 12. Subtract that from 13, that leaves you 1. Your y, 26 divided by 3 is 8. 3 times 8 is 24. Subtract that from 26. That leaves you 2. Your z, 12 divided by 3 is 4. And there's your answer. All right. I'm going to write it a little pretty. That should be 20. So it'll be 20, hang on just a moment, x to the 4th, y 8, z to the 4th, a cube root of 10xy squared. Question. Which 3? The root. I'm dividing by the root. It's a cube root, so you divide by the 3. Okay. Look at your x. You've got 13 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, take a look. You see how there's 3 of a kind? 1, 2, 3, 4. X to the 4th. Do you see the one left over? That one stays under the radical. That's what you're trying to do there. Okay? Number 13. All right. This time you are going to rationalize. You're not allowed to have a square root underneath. So if you take a look, to rationalize, you multiply the numerator and the denominator by the denominator, just like that. Okay? Now I'm going to show you guys step by step. Square root of 18, when you multiply, you just have to go across, same root. 18 times 10 is 180. Divided by square root of 10 times the square root of 10 is square root of 100. Okay? I'm moving there. What's the square root of 100? 10. Okay? You need to simplify this. What are some factors that multiply to give you 180? 90 times 2. How about 90 times 20? Okay, let's do that instead. The reason is 9 a perfect square root? Yes, and 3 comes out. How about 20? I'm going to keep going. You could do this a little differently. You got 3 square root of 20. What number multiplies to give you 20? 4 and 5 over 10. You guys see that right there? Many different ways to do it. Do you see a perfect square? What's the square root of 4? 2. Multiply them together. 2 times 3 is 6, with a 5 left over. Square root of 5 over 10. Okay? When you get to this part, take a look. Don't look at the square root anymore because you're done. Can I simplify 6 and 10? What does that come out to be? 3. So it's 3 square roots of 5 over 5. Okay. Actually, there's a plus and a minus because it's a square root. Half credit if you don't put that because it's a square root. You are simplifying. Could you have done this a little differently? Yes. For 180, okay, take a look. Let me get out of that. Isn't 180 divided by 36 gives you 36 and 5? What's the square root of 36? 6. Do you guys see how you could have done that right off the bat? Many different ways you can do it, okay? All right, number 14. Here we go. On number 14, you have to rationalize. Square root of 100 times the square root of 100, okay? You could have skipped this step as well. All right. If I had skipped this step, what's the square root of 100 times the square root of 100? 100. But I'm not going to do that. What's the square root of 100? 10. Do you see how I can just take off this part right here and do that? Okay? Because the square root of 100 is 10. Did you just get rid of your radical sign? All right. Then I can just deal with this part, correct? Factors of 12. 4 and 3. Do you guys see a perfect square? What is 4 a perfect square of? 2. So this here is 2 square roots of 3. Okay? Now I'm going to rewrite it easily. All this over 10. So you got 2. Leave yourself some space with the 3 left over. Okay? Look at your x. X to the 5th. There you go. What is 5 divided by 2? What's 5 divided by 2? 2 with a leftover, 0.5, correct? Okay. Y to the 9th. What is 9 divided by 2? What's 9 divided by 2? 4.5. And here's your 0.5. See how you have that left over? Z was 2 divided by 2. 1. Anything left over? So there's your answer. But I am not finished. Take a look at your number. I think I forgot to do that on your review. Can I simplify that? All right, so your answer is actually x squared y fourth z square root of 3xy over 5. There's your answer. You guys double check, make sure I did that on your review. That's on that you took a picture of, okay? So. All right. It actually is a plus and a minus. Yes, ma'am. Okay, number 15. Moving on. All right. For you to add or subtract, your root has to be the same, and your radicand has to be the same. When multiplying, only your roots have to be the same, right? Because you guys haven't learned exponentials yet. All right. At this moment, can I add all these or subtract all these? No, because your radicands are different. Could you simplify them first? Absolutely. Use this little sheet to help you, okay? Square root. What number goes into 8? 4 and 2. Did you guys see a perfect square? 4 comes out as 2. So 2 times 10 is 20 with a 2 left over. You guys see that right there? This one, factors of 300. Look at your square root. Now, you can use your calculator to help you. Try 300 divided by 100. Does that work? Okay? And you can look at your sheet. Look at your square root. You see how there's 100 right here? Use that. So this is 100 times 3. What's the square root of 100? 10. I don't know why I wrote 3 there. Sorry. 10 times negative 3 is negative 30 with a 3 left over. You guys see it right there? Can I add these guys or subtract them right now? No. All right. Next one. Factors of 50. 25 and 2. What's the square root of 25? 5. So 5 times negative 8 is negative 40 with a 2 left over. Can you add or subtract some of these components, these terms? Yeah, right here. Do these two have the same radicand and a same root? Yeah, so combine them. What is 20 minus 40? Negative 20 square roots of 2, and bring down your negative 30 square roots of 3. Okay. Not too bad? All right. Number 16. Moving along. Okay. Same concept. Your roots and your radicand has to be the same. All right. Factors of 48. Okay. What is factor of 48? 12 and 4. Now I'm going to give you guys a little hint. I'm looking at a square root, 48. You guys see a square root right here? All of that? 48 is somewhere in here, okay? It is close to 36. So what if you were trying to divide it by some numbers first, like 48 divided by 16? Did that work? So you think it might be a better idea to use 16 and 3 instead of 4 and 12, and then having to simplify some more? Absolutely. You could do it a different way. I'm going to use 16 and 3. And the reason I'm using 16 is this. Do you see how that's a 16? Okay? You could start off at 4. You could have gone 48 divided by 4. When you do that, you see how there's still a positive root, perfect square in here? Skip that one. Go to 9. 48 divided by 9. You get a fraction. That doesn't work. Try your next number in your series. 48 divided by 16. Any perfect root in 3? No, so use that number. That's something you can do to help you make it go faster, okay? But you can use 4 and 12. All right. I'm going to use 16 and 3. Square root of 16 is 4. So I got 4 square roots of 3. Okay? Factors of 27, 3 and 9. You guys see a perfect square? 9. Square root of 9 is 3. 3 times negative 3 is negative 6 with a square root of 3 left over. Okay? Factors of 75. Think of quarters. 25. Oh, that is correct. That is 9. I'm so sorry. I was adding in my head. Thank you. That is 9. Square root of 25 is 5. 5 times 2 is 10. The square root of 3 left over. Take a look at your roots. Take a look at your radicand. Are these guys all the same? Can I add and subtract them? Absolutely. So, 4 minus 9 plus 10 comes out to be 5 square roots of 3. Do not need to add plus or minus because you're adding and subtracting. Okay? You're not simplifying. So you're good. All right. Number 17. 17, you are distributing. I'm going to show you guys a step by step. And then on 18, we'll go a little faster. Okay? Here you go. Number 13. Everyone see these set of parentheses right here? 17. So that means you multiply. So you're going to take square root of 3 times the square root of 3. You see that right there? Then you have plus square root of 3 times the square root of 15. I'm just showing you step by step. You can't actually skip this part. Okay? What's the square root of 3 times the square root of 3? 3. Plus, what's square root of 3 times the square root of 5? Square root of 15. Any perfect squares in 15? No. Can I combine these two? No. There's your final answer. Okay? But I wanted to show you guys this part right here, what you were doing. This is the step-by-step part. And then you always simplify. Number 18. Okay? I'll show you the step-by-step on this one. You can actually skip this part that I'm about to show you. See the parentheses? What number is in front of that 15? A 1. Outside stays outside. 1 times 4 is 4. Bring over your square root of 15. Okay? Next part, plus square root of 15 times the square root of 5. Correct? Okay. So now you have 4 square roots of 15 plus, what's the square root of 15 times 5? What's 15 times 5? 75? Okay. Factors of 15 is 3 and 5. Can I do anything with that? Nope. So you bring it down. Factors of 75. What are factors of 75? 25 and 3. You guys are getting so good at trying to recognize perfect squares. Pull them out, okay? Square root of 25 is 5. So you got 5 square roots of 3. Take a look at these two terms. Can you guys add them together? No. One's the square root of 15, one's a 3. So there's your solution right there. Any questions?